All right. Make sure my mic's on. Yes, okay. I don't know if my share screen was on or not. Okay, here we go. All right. Hope we all had a good weekend. Per usual, you have your due dates and stuff on the quote board right here. So 6.1 homework's due tonight, 6.2 is due on Wednesday night. I'm just going to go ahead and make 8.1 and 8.3 due on the 6th, which is going to be our last day of class. I did assign a video quiz on chapter 6 and 7. I know we are not technically covering chapter 7, but there's nothing wrong with watching a single video on it. So that's going to be due in Canvas. Make sure that you submit, turn in your Word file, or whatever your text file, where it says submit chapter 6 video quiz here. I don't have that title exactly, but under that quiz section, there's a section, there's a link for the actual quiz, and there's a link for you to submit it. So it makes it an assignment grade, so that way I'll be able to grade them and you can see your grade later. But the thing I had posted originally was not an assignment, and I didn't want to have to go back and re-edit it. Your next Excel homework is due tonight on 5.2 population. Please make sure you are reading those instructions very, very, very carefully. If I remember correctly, this is one of those that if you don't follow the instructions to a T, the graphs don't, it might come out right, but Excel thinks it's wrong with that auto grading system that I can't really do anything about necessarily. So please make sure you're following instructions. I know one of you emailed me about that. I haven't had a chance to respond because I just saw the email basically 5 minutes before class. So I'll get to that later. Then your final Excel assignment will be 9.2, and it says dash 9.4 after that, mutual fund. This is going to be very, very, very similar to the Excel file I built in class last week for us, or several Excel files actually, where we had a starting amount, and in some instances that was our only amount, and we just saw the interest over time. Then we also had a problem where we had a starting amount and we were adding money to it each time. The homework problem is more similar to that one because with mutual funds, you typically add to the pile over your life. And I think the only thing that might be different about that one, and don't hold me to this, it might be that your deposit changes every year. It might increase by 2 or 3% every year, which I showed you how you can account for that as well. Your formula sheet for your final exam is in Canvas. It's under the review section. The final exam review will be posted no later than Monday. I really want to have it by Friday of this week, but I'm not guaranteeing yet. So I don't have a date written yet. So that's going to be soon. And then the final exam is going to be Wednesday the 6th. Wednesday the 6th, you will only get 1 day for this. You will only get 1 attempt for this. So this is going to be different than the midterm. I believe I'm not allowed to give multiple attempts on the final exam. If I am, after I talk to my department head, then I'll say, okay, I can give you 2 attempts, but don't expect that. Please expect only 1 attempt. If I can give you 2 attempts, then you'll see that particular note change in the videos as we go. But it will be 1 day only, so it'll be posted at midnight on the 6th, 12:01 a.m., whatever, and then it's due by 11:59 p.m. So please make sure you have studied before this. Please make sure you've worked on the review before this. You've got all your homeworks done, and that you are ready to take the test that day. If you are not going to have access to the internet that day for some reason, you need to get a hold of me ahead of time so that I can assign you a different day for you to take that test. I'm going to start talking about how final grades work soon, but you should your quantitative reasoning students, you're supposed to be reading things and paying attention. Guess what? You're getting emails about this. Your emails say that you're going to have to submit something in Canvas for the most part by a specific date. And the fun thing is we're not even getting as much information as y'all. They might say, oh yeah, ask the faculty. We don't know everything yet, and things are changing from day to day. We have special situations with certain students that things are still being ironed out, which is why I haven't wanted to say anything officially about this in class yet. Again, they're giving students information that they're not giving us, and they're also changing things as this goes. But the basic idea is that if you don't, most of you at least, if you don't want to receive a letter grade, if you just want to receive a pass-fail grade with no GPA effect, you have that option. Emailing me is not the way to tell me what you want to do. You have an official form to submit, and then I give you a grade based on the form. So again, more discussion with that later. Let's not waste too much time because we need to talk about one more thing from chapter 6 and then dive headfirst into chapter 8. So that one last thing we need to talk about from chapter 6 is APY, something we've talked about before, but now getting an APY based on an APR. I think I said chalked there. I haven't used chalk in a decade. We talked about APY, annual percent yield, back in chapter 1. We said that, all right, we have this loan or this credit card or whatever it was. I think we did the TV on layaway or something like that, interest-free for a year, basically. And we said, okay, well, if we do end up paying it, the interest still accrues. So here's the interest from month 1. Here's the interest from month 2 through 12. You add them up to get the total balance back. And it was like a 12% APR, an annual percent rate on the loan. But if you actually calculated all his interest, because as your loan increases, the interest increases each month, it has that same snowballing effect of compound interest, but against us. It's actually against our favor instead of for our favor. So that 12% APR, because you get compound interest on your that you owe, you end up owing a little more than 12% over a year. It ends up being like 12.5% or 13%, depending on how the math works. And we'll actually do that as an example coming up here shortly. So APY is the effective rate over 1 year, the effective rate over 1 year. So it's not over 5 years, it's not over 10 years, it's specifically 1 year. So an APR, so a prescribed APR of 12% may have an effect of, after a year, you really owe like 12.2 or 12.5%. Now they're generally pretty close to each other. The bigger the APR, the more further apart they are. So, you know, an APR of 1% may have an APY of like 1.01, whereas an APR of say 20% may have an APY of 22 or 23%. Okay, so for our example, our first example, let me make sure I can have some space. Example, I don't know what number we're up to, honestly, so let's just say example X. This will be A. Bob deposits, I can spell deposits, some money into an account that accrues interest monthly at 12% APR. What is his APY? In other words, effectively, how much percent back does he get? How much percent does he get back for free after 1 year? Or if this was a loan, how much does he actually have to pay? Notice I didn't have to tell you how much money he deposited or borrowed. APY, this formula, which is on your formula sheet, is only based on 2 variables. The R, which R is APR, and the N, which is the number of times you compound in a year. So for this problem, our APR is the R, which is 12% or 0.12 as a decimal. The N, since we're compounding monthly, would be 12 months in a year. Quarterly would be 4 months in a year, which means every 3 months. And that's an aspect that a lot of people messed up on that project. A lot of people divided by 4 instead of 3. Yes, N is 4, but there's 3 months, and you were supposed to be dividing by 3 because 3 months in a quarter. That was a mistake that a lot of people made. Okay, so our APY, the effective rate over a year, that's what that means, is 1 plus 0.12 over n, which is 12, raised to the n, which is 12, then a minus 1. I'm going to circle something, and well, I'll highlight it and then erase it. This right here, this formula, this part of the formula, 1 plus r over n raised to the n. Look how similar that is. Let's go back to this. 1 plus r over n, 1 plus r over n raised to an nt, raised to an nt. Those are all very similar parentheses bits. The only thing that's missing that's in these two, what's missing from the APY formula is the t. And the reason the t is missing is because APY is only relevant for 1 year. So the time has to be a 1. So basically the t is a 1, which means it's there. We just don't need to write it. It just doesn't have the p because a rate is not dependent on a deposit. It's only dependent on the APR and how often we compound. And the more often we compound, the higher the APY tends to go, but with diminishing returns. The other thing that's up there is this minus 1. The minus 1 there is basically taking off the 100% that's the base. This parentheses, let's say the APR was 12. This parentheses ends up being 1.12, with an extra little bit of change. So the minus 1 subtracts off that 100% from the base. So that's why that minus 1's there in the formula. Now in this formula, all we got to do is pull out a calculator, we turn it on, and we type that. So parentheses, 1 plus 0.12 divided by 12. Close the parentheses, raise it to the 12. I didn't have to pre-multiply the exponent this time because there's nothing to multiply. Then the minus 1. Now, if you have a calculator that when you hit your exponent, if it makes your numbers smaller and actually look like an exponent instead of like what I have, you're probably going to have to hit the right arrow to get out of that to do the minus 1. So again, if you have a calculator, a fancy calculator where that minus 1 is up there in the exponent, it looks a little smaller, make sure you hit the right arrow to get out of the exponent. Drum roll. And we get 0.126825. Let's round this to 4 decimals. So 0.1268, 0.1268. So this is, oops, I'm still on highlighter. I don't know why it keeps going back to the blue pen. 0.1268, which when you convert that to a percent is 12.68%. That is the effective annual rate. So if you borrow money at 12% and it compounds monthly, or if you deposit money and it's gaining interest at 12%, which is insane, monthly, the effective rate you would actually gain over 1 year, 12.68% of your base value. Now, maybe you don't trust that. Maybe you don't believe that. Actually, I don't want to do it with Excel. It's going to take a longer time. Do you believe this? Well, the future value, let's say you have to have a deposit amount. Bob deposited $100 on all those conditions. So his future value, A, and the formula is P parentheses 1 plus R over N raised to the NT. That's the formula. So that's $100 times 1 plus the 0.12 over 12 raised to the 12 times 1. And this is for 1 year only. So that's 100 times 1 plus 0.12 over 12 raised to the 12. That's 100. You may have to hit times before your parentheses, depending on your calculator. Then 1 plus 0.12 divided by 12. Close it, raise it to the 12. So that says after 1 year, he's got $112.68. $112.68. Which means that his interest in 1 year is the $112.68 which was the future value, minus what he deposited, which was 100, and that's $12.68. Where your interest rate over 1 year is just the amount of interest divided by how much you deposited, which is $12.68 divided by 100, which is, guess what? 0.1268. That's your effective rate. That's your APY. Interest over principal was the original formula we gave you back in chapter 1, the simple formula. The APY is interest for 1 year only divided by the principal. That was a previous formula. It was a ratio. But now we have a more complicated formula. That way we don't have to calculate the annual interest. Now, does that mean you have to use it? No, you can calculate the future value. You can then subtract to get the interest, and then you can divide by the principal to get the APY. We are giving you another method. That's all we're doing here. So 12% APR has an effective yield of 12.68% because we got a little bit more than than 12 bucks. 12 bucks would have been 12% interest. But because of the compounding, we get a little bit more. We actually get an extra 68 cents, which causes our effective interest rate over 1 year to be 12.68. This is what we've talked about how, okay, when you apply for a credit card, it may say, oh, your interest rate, your APR is 20%, but the APY is 21%. Or maybe when you go get a mortgage or a car loan, the APR is 3.2%, but the APY is 3.25%, maybe. Let's do a credit card. So we'll do one more of these and move on to chapter 8. B. Bob deposits blah, 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 or borrows. Let's say he borrows at an APR, an effective, not effective rate, a annual based rate of 24%. 18 to 24% is pretty common for credit cards, 24 if you have lesser credit. And we're going to say it compounds monthly. It's how credit cards compound interest. They compound monthly. Okay, well, that says that the R is 0.24, 24% is 0.24, and the N is 12. So our APY should be, going back to the formula, which you don't have to memorize, parentheses, 1 plus the R of 0.24 over the N, which is 12, raised to the 12th power, then a minus 1. A lot of people will forget the minus 1 because they're rushing and not paying attention. This course is all about not rushing and not paying attention. I can just type this all in my calculator all at once. On my screen, parentheses, 1 plus 0.24 divided by 12. Close it. Raise it to the 12. Hit right if you have to. Again, I can't tell you who has to and who doesn't. Figure out your calculators. Practice this on your own. Don't just follow me. Minus 1. Hit enter. And we get 0.2682. 0.2682. Which is a percent, would be 26.82. That's our APY. So getting a credit card that accrues monthly at an annual rate of 24%, really, if you slice that up over a year, you end up paying almost 27% as an annual rate. So paying 24% compounding monthly means if you wanted to have a similar annual compounding rate, it's about 27%. So that compound effect, the larger the rate, the larger of an effect it has with the compounding. Compounding at 12%, it only bumped it up to 12.68 in terms of what we actually feel. That's what effective rate means, what's felt over 1 year. But this 24%, it is a little bigger of an effect. It's almost 27%. It's 26.8%. So that's our APR versus APY. And with that said, we can go into our Chapter 8 notes. And then one more memo on this that I've mentioned previously. And these problems can be in chapter 6, chapter 8, or chapter 9. They're littered all over the place. I'm not saying you're going to see them all over your homework. I just mean in all of the homework questions. So you might see one of these in chapter 8. You might see one of these in chapter 9, which I'm not even going to honestly grade the homework on. Spoilers. But we'll still get to talk about it a little. So any problem that asks you to find the APR given an APY should be skipped. Also, any problem that asks you for an average rate of turn should be skipped. This is something that's covered in 6.4. We are not covering 6.4. That these things involve logarithms and nth roots. These are just applications that are a little above what we want our quantitative reasoning students to be able to do. They are awesome formulas. So we can go from APR to APY, but not from APY to APR. Anytime you're asked for an average return, just skip it. Those homework problems will not be graded in my official grade book when I have your grade with a plus 10. As well as a couple other corrections that I've had along the way. Okay. So chapter 8, we're going to do 8.1 and 8.3. And these are going to be briefly done. I could knock this out in one day if I really wanted to. We're going to take about a day and a half, roughly. Causation, correlation, and confounding factors. Oh, and I meant to open up the text. Give me about 60, maybe 60, 75 seconds to let me open that up. All right, didn't even take that long. Luckily, I already had my math lab opened. So, see text example to discuss the link between Walmart and obesity. Let's do that in a few minutes. I want to talk about these definitions first and causation versus correlation. Causation, correlation, similar words. They end in un. They both start with ka, and they got a few syllables. The word causation has a root word cause in it, cause and effect. So causation says that we have a change in one thing causing a change in another thing. Kind of like our country is not just shutting down their borders absolutely, caused coronavirus to spread from one nation to another. That's causation. Cause and effect. One thing happening directly affects another thing happening. That's causation. Correlation means that you're seeing two things change, and they seem to change in respective ways, but it does not mean necessarily that one caused the other. It's just, it happens to be, maybe by coincidence, that these two things are changing in a similar manner over similar time spans, or whatever it is we're talking about. So an increase in one variable, apples, might also see an increase in the other variable, oranges, or decrease. One can go up and the other can go down. We can have positive correlation or negative correlation in the same way that we can have positive or negative variation. In other words, direct and inverse variation. Proportionality, variation, all these words mean the same thing basically. Correlation does not imply causation. Just because two things correlate, just because a pair of data correlates, does not mean that one caused the other. And let me tell you, in terms of data analysis, this is one of the biggest issues we have in the world of 2020. It's always been an issue, but now that we have the internet, we have Anybody can put anything on the internet. I mean, look at Wikipedia. It's a great site. Lots of people use it for their research papers, whether they should or not. But literally anybody can go on Wikipedia and edit it. So we have too much, what's the word I'm looking for? The ability for too many people just to say something, and then other people can read it, and then, oh, somebody said it, it's true. Oh, okay, the store sold more apples and it sold more oranges. So the sale of apples directly correlates to oranges, and I can always expect if the apple sales go up, the orange sales go up. Yeah, that might be fine on a short-term scale, but what about when a whole world of crops of apples can't be sold because that particular farm had a coronavirus outbreak or something like that? So we still have oranges, but not apples. Or what about if it's just two things that we're trying to say, oh, well, yeah, one thing causes the other. If you eat too much sugar, you're going to get diabetes. Okay, well, yeah, it's typically seen that sugar intake typically corresponds with the more probability of getting diabetes, but does that actually mean there's causation? And I'm not saying there isn't. My personal beliefs of that is that it does, but I'm not a doctor, so I'm not going to say that's what it is. We've seen a lot of studies with cholesterol versus heart disease. And a lot of people will say, well, there's correlation, because if you look at this group of people who all ate twice as much meat as another group of people, they were twice as likely to have a heart attack or just some type of coronary issue. But there are confounding factors in data, especially when you're talking about people. Okay, yeah, person or group B who all ate twice as much meat, yeah, maybe they had more heart attacks, a higher probability of heart attacks. But what about the rest of everything they're eating? Are they eating twice as much bread? Are they eating twice as much processed food, twice as much trans fats, twice as much sugar maybe? So especially with people, there are tons of these what are known as confounding factors. You'll see that definition on the screen in a little bit. I just don't want to reveal too much. But there's a lot of stuff that we don't necessarily take into account. We just say, well, I'm only worried about this one thing. Let me just focus on this one thing, when there's 10 other variables at play that could be the actual cause. So causation, correlation, not the same thing. So here's an example of that. And I said, just because somebody has data with similar trends does not mean one caused the other. There can be correlation, but not necessarily causation. Since the 1800s, the pirate population has been steadily shrinking. Fact. Since the 1800s, the average global temperature has been steadily increasing. Fact. Now, whether you're against global warming or anything like that, you cannot deny that the average global temperature has been steadily increasing. I'm not talking about global warming with that. This is just a fact. This is just data. So that's correlation. Since the 1800s, the pirate population has been steadily shrinking. Since the 1800s, the average global temperature has been steadily increasing. So these are correlating in a negative aspect. In other words, as one goes up, the other goes down. So maybe they're maybe they're inversely proportional versus one going up and the other going up. So that's correlation. This data right here correlates. One has been going up steadily, the other has been going down steadily. That is correlation. So then what somebody on Facebook or on some random news website or just some troll, whatever, is going to say that pirates have caused global warming. Global warming. OMGs, LOL, BBQ. Pirates cause global warming. It's all their fault, right? We need to stop the presses. We need to get the word out on this. Pirates are causing global warming. Where's your proof? Give me some proof. Where's your evidence? Just because two things happen, just because they have a pattern, does not mean one caused the other. This is a massive problem with our society, in politics, in science, everywhere. So, confounding factors. These are the real, often hidden variables behind correlation. And no, this has nothing to do with Scooby-Doo. Sorry for my silly joke. But it does sound fun to say if it wasn't for those confounded teenagers, we would have gotten away with it. So that correlation of the pirates versus the global temperature, the confounding factors are everything else that's caused global temperatures to increase and everything else that's caused pirates' population to shrink, like civilization, you know, becoming more and more technological. So we don't have a bunch of people just sailing the open seas as much. There are still pirates, but not as many as there were, say, in the 17 or 1800s. So they don't really have anything to do with each other. They just happen to correlate. Now, in the real world, the biggest issue is showing causation. That's what scientists are meant to do, to show causation. Sometimes they do okay with it. Sometimes, honestly, they suck at it, usually because they're probably being paid by someone else to do something specific. So they want to get a bonus. So they say, oh yeah, that specific thing happened. Look, it correlates. And here's one thing that causes causation. Yeah, but for every one thing that you say causes causation, there might be 20 that don't. Now, in this class, we're not really going to study cause and effect. You might have a homework question just using some basic logic about it. But again, we're not really going to be studying causation. We're going to study correlation. How, in other words, we're going to have a bunch of data, some real world data plots. We'll do an equation. We'll make Excel give us a line of best fit or a curve of best fit. We'll get a certain value in R that I've mentioned in the past. And then we'll talk about how well the data correlates, but we won't really talk about causation necessarily. So before we get to the next section, obviously, let's go back to that link between Walmart and obesity. So textbook, and we do have some worksheets I want to do as well. So this Walmart problem. Spread of Walmart supercenters linked to obesity. Read the March 9th, 2011 Harvard Business Review Daily Stat headline. Caption went on to state, I'm not going to read this whole thing. Blah, blah, blah. One additional Walmart supercenter per 100,000 residents in an area increases individuals' probability of being obese by 2.3 percentage points. Oh my, they said percentage points. These people know what's up. They know what they're talking about. Our math teacher was talking about this quantitatively. A percentage point, this is when we're talking about a change of a percent. So we have total change and percent change. But we don't like both of those to have the same unit. So percent change, we left as a percent, but total change, we said use the phrase percentage points. It still means percent. But I know that because they use percentage points, we're talking about a total change. So maybe it goes from 1 to 3.3 or from 11 to 13.3 one year versus the next. That's not a percent change, that's a total change. So if you put a Walmart in an area with 100,000 people, it's going to increase their obesity by 2.3%, the probability of becoming obese, which means you have a certain body weight ratio percentage. I don't remember the number off the top of my head, but you just have a certain one. And whether or not that value is accurate for representing an obese person or not, you know, correlation, causation. If you have someone really tall and muscular, that value can end up, you know, being skewed. Okay, not the point of the problem though. So they say Walmart explains 10.5% of the rise in obesity since the late 80s. And then they go on and talk about some other fun articles. Blah, blah, blah. Read it carefully. Try to understand what they're saying. We did that. Read it again, read it again, read it again. Try and think about how they would possibly measure such statistics. So some other headlines from this Harvard Business Daily Stat were mobile phone purchases reduced tobacco use in the Philippines. So in the Philippines, they saw some correlation. They saw correlation that the more people used their cell phones, the less they were, say, smoking cigarettes or whatever in this one particular country. So that means people need to use their cell phones more so that they'll smoke less. Then there's another one that thin men get lower pay than average weight men, not in a specific country, so that's worldwide, or maybe just US. So the thinner you are, the less money you're likely to make. That sucks for me. Maybe I need to go eat a bunch of cheeseburgers and pizza or something like that, gain 30 pounds, and then I can finally get a better paying job, right? Ha ha ha. Maybe I just shouldn't be a teacher. Thank you, state employment. But I'm happy to still be getting paid. Then they also say a few others, and then they put this together all in one big chunk that men who are thin from smoking should buy an iPhone in Manila, which is in the Philippines, and move next to a Walmart center in order to get a raise. Man, if that doesn't sound like Facebook news to me, I don't know what is. I mean, that just sounds like there's so much, what's the term, hyperbole. That just sounds hyperbolic. It sounds like an extreme exaggeration clickbait title for a news article. Smoke to get thin, because there's a correlation there as well. Might even be some causation that would be believable. Smoking will make you thin, and then you buy an iPhone in Manila, move next to a Walmart so that you'll get fatter. That way you can get more money. So the ultimate goal of that is to make more money. Terrible. That's just a lot of correlation. Okay, so let's move on. Let's actually get back to this Walmart problem. Blah, 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 correlation. They even go that they sound precise because they use phrases like percentage points. They talk about confounding factors that, may have actually been the cause of those different things, being thin and making less money. Maybe it's just that the average thin person is sick and not employed. Maybe there's something like that, or unemployment. So read that page, and then this is the graph that I wanted to get to. And this is when I really wish I had all your voices in a classroom to chat. Unfortunately, it doesn't really work well on Canvas. I tried this in one of my classes, and I had so much feedback, it was insane. So we'll just pretend like I'm asking you questions and that you're answering. So here's a graph, and this has two different types of data on this graph. Let me pull up my annotation. So unannotate, zoom in, there we go, re-annotate. This kind of looks like a line, but it does bend a little bit here and there. This is representing the obesity rate. So this right here just going over it in red. Sorry about the little bump there. That uses the right-hand side's values. So down here in 1980, we can see that the obesity rate was about 0.16 or 16%. So these are his decimals. Let's say in 2004, up here, about here, that says it's about 32, 33% obesity rate. That's a big climb in 30 years, 20 years, 25 years. But down here, the Walmart supercenters, that's the number of Walmart supercenters. It's just pretty much flat line here because there weren't Walmarts until a specific year. And then all of a sudden there's an explosion of Walmarts. And it's curving. It almost looks like a line, but it is an exponential curve, arguably, in this region. And it'll flatten out, become logistical at some point. But we could also just argue it's a line because it's a short time. And it's not, we don't see an explosion like this. So what's happening here? All of these are the number of Walmarts, and that's on the left side. First of all, I have a major problem giving the average American a chart with two completely different types of information on that, measuring it against it, because why is the left side, why is the height of 1,000 Walmarts, why is that visually the same height as a 16% obesity rate? Why is a height of 2,500 stores visually the same height as a 40% obesity rate? Somebody chose to make these numbers relate to each other in that way. I could redo this whole thing, and I can say that right here, this is 10 Walmarts. And then on the right side, this obesity rate is 0.5. So I can make it visually feel like a 50% obesity rate, it feels like, oh, it's 10 Walmarts. Because by the time you're in 1993, so here's 1993, that's 10 Walmarts. And then just visually that says, oh man, that's relating to a 50% obesity rate. But it has nothing to do with that. So they're already trying to confuse you just by scaling one to another in a certain way. Now, what's likely in a lot of scenarios is that Excel decided to scale it this way, but someone else can then come in and manipulate it to throw off people. So the number of Walmarts is very flat because there's no Walmarts until 88. They say the first supercenter opens in 1988. So right here, this is our first Walmart. And visually, you can't even see it budge because right here is 500 Walmarts. So you can't see it budge, which is why it still looks flat until about 1993 when there's 10. But Walmart really started getting some money coming in 1993. Now, we are talking about supercenters. I'm not exactly super into Walmart. I actually haven't shopped in a Walmart in almost a decade, just for personal beliefs. But not the point of this problem. When they say supercenter, I'm assuming that they're meaning the grocery store ones, because I feel like they were more regular Walmarts than 10 in 1993, because we had a Walmart in our area, and I just can't imagine that we had one of the only 10 Walmarts in 93. So I'm assuming these are ones that had groceries too, which pretty much all Walmarts do now. I'm sure there are some that don't have grocery stores, but anyway, not the point. So they were 10 in 93, but then look at this massive jump. This was kind of like an explosion. It feels like it, of 239 in 1995. So I would definitely say exponential growth. We just can't see it because there's an explosion all of a sudden, but it tapers off eventually. So there's 239 in 1995. So that's where we're about halfway between the 0 and the 500. And then there's 1674 in 2004. So just a little above the 1500. So they got a whole lot of revenue in the early 90s, which then funded them opening a whole bunch more Walmarts. Okay. The obesity rate was about, again, 16% in 1980. If you go to 92, it was about 25% roughly, and it just gets worse every year. And it was about 35% in 2004. Now, it did kind of flatten just a little bit temporarily, and I do want to erase everything that I've written now so that you can see what it looked like originally. I guess I could just clear my screen. See, it flattened here for just a hot second, right around the time Super Size Me came out. I'm not saying that is causation, it's just correlation. But then it just picks up speed again. Okay, so they want to say, based on this graph, why do you think that some researchers said that obesity is caused by Walmart supercenters? Well, look at this. They're both going up. Walmarts are going up, and the obesity rate is going up. So therefore, Walmart causes obesity because they're both going up. That is a terrible, horrible, garbage argument because you just see one thing going up and the other thing going up when you're talking real world data, when you're talking real world science, when you're saying causation, not just correlation. Here's why this is garbage. The obesity rate, let's just break this down here. Before and after Walmart supercenters, basically. After, the obesity rate is climbing at about the same rate. This rate is roughly the same as before. The slope here is equal to roughly, if you just call these lines, the slope here. Slope corresponds to rates. So the rate doesn't really change before and after Walmart opens. In fact, if Walmarts were causing obesity, because this is the rate increasing for Walmarts, the number of Walmarts increases, then this slope should be getting steeper. If Walmart caused this, you should see this thing get steeper like that. If Walmart was having a huge causation to the obesity rate, then Walmart's proliferating, which means being more and more numerous, spreading, should cause that obesity rate to not necessarily skyrocket, but it should have changed at some point. Also, before the Walmarts were even around, obesity was already climbing. It was climbing, it was climbing, it was climbing, it was climbing. And again, once Walmart came out, it kept climbing and pretty much at the same rate. It had a small little pause right here, but overall, no, Walmart didn't really have an effect. At least not just Walmart. I would say it's Walmart and Food Lion and Kroger and Harris Teeter and Taco Bell and McDonald's and Wendy's and Hardee's and KFC and more access to foods that maybe our bodies don't necessarily appreciate, maybe don't burn as easily, or maybe we're just taking in more calories. Maybe we've become more sedentary over time. Maybe our food is more heavily processed, unless we're eating whole organic, blah, blah, blah. Maybe that has an effect on our bodies. Maybe the change in us eating highly saturated fats to highly unsaturated fats, which while again, you'll have some scientists say saturated fat's bad for you, you've also got some scientists that say saturated fat is good for you, and that unsaturated fat is actually one of the leading causes of diabetes because cells in your body can't process it and they just shut down. There's a lot of fun science. If you actually want to learn something, you can go and find this information. And again, I'm not telling you one thing is causing another. I'm saying that you can go out and form your own opinion by looking at research, not just reading one article and going, yep, that's it. That's what it is. Think. That's what I want you to be, is thinkers, analysts. Okay. So let's clear our screen. Let's move to another page. There's another page, and this is great that it's actually in color. This also tries to say Walmart causes obesity. Let me zoom in a little, because those blue dots are kind of hard to see otherwise. So we've got some charts, graphs, pictures, whatever, of obesity rates as heat charts. So the color, the warmer the color, the worse the rate is. That's typically how heat charts work. So this magenta and dark red, that's when we're getting to 25 and 30% or higher. This kind of peach or yellow is 20 to 24. Your blues, your cools are less than 10. A white means there's no data. Generally, we're talking about, pre-internet days, and we just weren't able to collect the data, which is why in 1990, there's a couple states without data. It's not saying that there's 0% obesity. It's saying there's no data. So you have to kind of ignore those states for the first decade, I guess. So 1990, oh, look at that. It's a nice, cool country. Most of these are in the 10% or less, at worst 10 to 14. Then in 2000, oh, okay, we're starting to see some darker blues. We're starting to see those yellows, which the darker blue is 15 to 19. The yellows or peaches, whatever, is 20 to 24. And in 2010, oh man, look at all those reds and magentas. This is terrible, right? This is a lot worse. The best states are now in the 20 to 24% region. The worst states are now higher than 30% obesity rate. And then they give you this thing that over here that's completely different, and it's 2009. Well, let's just say it's 2010 since it's a year off. And all these little blue dots basically represent a Walmart. So I'm not going to say it's perfect. You can't really count the dots in any particular region. You see a lot of dots in East Texas. I'm not exactly sure why that is, why they're all on top of each other. You got a lot of dots in like the Houston region. You get a lot more dots in this region right here. You got a lot in the Southwest region of North Carolina, decent amount in Florida, none in Nevada. Very, very few overall in just the Midwest in general, and only a couple here and there in California, Oregon, and Washington. So this is showing that most Walmarts are on the eastern side of our country. And then what they expect you to do to correlate and think causation is to look at this chart and even this chart and say, well, over time, the worst countries in terms of obesity rates have tended to be on the eastern half of the country. New England's kind of an exception. You also don't see as many Walmarts in New England. But look at 2010. I mean, you could practically split this thing almost down the middle, cut it off at Texas and the Panhandle right there. And the right half of the country, way more obese than the left half of the country. Look at this. The right half of the country has a lot more Walmarts. Oh, okay, so the Walmarts must be causing the problems. No, it just happens to be Walmarts tend to be in denser populations. So you're not just gonna have Walmart sitting in the middle of a field in Missouri. Sorry, I had to say it that way, or Nebraska or Montana. You're not gonna have a Walmart sitting right next to 4 presidents, as statues, their heads in a certain Dakota, because there's nothing out there. Why would you have a Walmart in the middle of nowhere? Walmarts are in denser populations. You might say, oh, well, okay, well, but there's lots of dense populations in California. Why aren't there a bunch of Walmarts here? Why aren't there a bunch of Walmarts here? Well, the West Coast tends to think a lot differently on average than the East Coast in many, 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 many ways, not just political, but also in the food they eat. So maybe they're living healthier lifestyles, making smarter choices. Maybe they're exercising more. And Nevada, well, I mean, Nevada's just interesting. I would actually think Utah would be the state that has no Walmarts, because Utah has got all sorts of weird laws. And that's in part because of who lives in Utah. Nevada, I guess, is just mostly empty except Las Vegas, and Las Vegas doesn't want a Walmart. I don't know. But again, the point of this whole thing is, my rambling aside, is to look at something and not just draw an immediate conclusion of something so complex, especially something involving people. There's a bigger picture out there almost always. Is there anything else we need to say about this? That's pretty good. Again, confounding factors, one more time, that is the often hidden reason that something is actually happening. And this page is excellent. And this can really, I really feel like there's going to be a ton of terrible data out there having related to the coronavirus, kind of in this manner. So the CDC announced in 2004 that obesity was the cause of 400,000 of the approximately 2.4 million deaths per year. We have a lot of death every year. And it's sad, but that's what happens when you have a lot of people. We also have a lot of births. Our birth rate's higher than our death rate, so we're growing. Not really the point of this, but just wanted a positive spin. However, the CDC did not control for a very important confounding factor, old age. So they said obesity caused 400,000 of the 2.4 million deaths. And if you look at that as a ratio to get a percent, our favorite thing in this whole class, 400,000 divided by 2.4 million is going to give you 17% rounded to the nearest whole. So in 2004, the CDC said that 17% of deaths were caused by obesity. However, they didn't think about the biggest confounding factor possible, which is old age. Older people, as you age, on average, you typically get a little heavier each couple of years, each 5 years, each 10 years, whatever, once you've hit full maturity growth-wise, 18, 23, 25, wherever you want to say that is. So 10 years later, maybe you put on 3 pounds. 10 years later, you put on 3 pounds. 10 years later, you put on 3 pounds. If you're following a proper diet, if you're exercising, and it's not necessarily 3 pounds, but it's just typically we gain a little weight over time in the long run. So because of that, older people tend to be heavier. They can't move as much. They hurt. So they can't exercise as much. They become more often sedentary. And they also die in greater numbers because they're old. They have other health problems too. So the CDC did not account for the fact that these old people were obese and had a coronary problem, or obese and had cancer, or were obese and had, you get the idea. They just said, oh, they were fat. They died from being fat. So then they had to go back and do a revision. And after they accounted for that, their later number, which you can believe or not, I'm not saying to always believe the CDC. I'm not saying to always disbelieve them. Later, they revised the number, and it was 24,000 deaths were caused by obesity. So they went from 400,000 to 24,000. That is almost 5% of the original value. It's like 6%. Let's see, 24,000 divided by 400,000. That's 6% exactly. So they went back and revised and said only 6% of the original deaths we thought were caused by obesity were actually caused by obesity. So originally they said 17% of deaths were caused by obesity. Now they're saying 24,000 divided by 2.4 million. That's only 1%. So because they goofed, because they didn't use their head brains, they didn't think fully, they didn't consider all issues, they went from 17%, here's my annotate, they went from 17% death rate to 1% death rate, just because they modified their analysis. And a 1% causation feels a little more appropriate to me, just dying because someone's obese. Now, being obese tends to cause other health issues, and those other health issues tend to then cause death. But you can't definitively say that the obesity absolutely caused the death in most cases. Could have just been they were old, could have been they had other problems, could have been a non-related problem completely. All right, clear screen. Take off annotate so we can scroll. Bivariate data, we're not really going to get into. This is a fun little chart of gasoline prices. One of them is scaled, the other is not. And by scaled, I mean scaled to CPI. So that $1 in 1900 is the same as $1 in 2000, which is not true. When you scale to CPI, you account for that inflation factor or deflation, which we might see for a couple of years, depending on how this goes. I'm curious if we'll see deflation or hyperinflation from us just printing money and giving it to everybody. So this kind of relates to a worksheet. I think that's the last page I need to show. So all that data, when they plot this together based on the price of oil, the price per barrel of oil, which some of you may have seen a fun article recently that oil prices went negative. Read everything carefully. That was oil futures went negative. That does not say you're going to get paid at the gas station to fill up. There's more to it than that. It just means that some oil suppliers had too much oil in their hands. They needed the storage containers. They needed to get rid of it. So they were paying other people to take the oil off their hands. That was like for a day. So they give us all these different data based on oil prices and how much we pay at the gas pump. These are not labeled in time. This dot over here was from 1999. This dot right here was from 1981. This dot right here was from 2008. So there's no aspect of time that you can actually see on this chart. It's coming from this data, where back in 81, we were up here. Back in 99, we were down here. Then in 2008, we spiked up here because of a hurricane shutting down some pipelines. That was really fun, paying $4 a gallon at the time. So again, this dot over here does not necessarily happen before this dot, does not necessarily happen before this dot. This 1999 over here, it's on the left, then there's a 1981 dot over here. So they plot all of these, and then they make Excel give a line of best fit, and this is what they come up with. And obviously it's not a perfect fit because these data points are, kind of clustered. They're not just in a perfect line. But this line does look pretty accurate in terms of a predictor. So if oil went up to $200 a gallon, or sorry, $200 a barrel, I could probably, to some degree, predict what I'd pay at the gas pump. I can't accurately predict it because taxes go up over time, and there are other issues. The cost to refine oil goes up over time. But this is the equation they come up. So here's how much it goes up per gallon based on oil price going up in dollars. And then there's our initial value. So this says that if oil was free, we would expect to pay $1.07 at the pump. If oil was free right now, I'd say probably $1.30 after taxes and everything, and refinement, but that's just a guess. Gas is never going to be free, even if oil was free, because there's other costs associated with it. And then they put this R squared, something we've seen once or twice in this class. That's what I want to talk about coming up. So this R squared is a measure of how well the data correlates. It does not say causation. It says it's a measure of how well the data correlates. All right, 8.2, hey, best fit, least squares, regression lines. These are things we've all mentioned. That's what Excel is doing when they give you this line. So sum of least squares, it's called a regression method. Again, we do not study that in here. We are not doing it. It would take us a month to figure out. We just let Excel do that thinking for us, thankfully. All we learned was the anchored approach, where you use the first and last point. And we said, that's fine, but honestly, this version is usually better. So we'll get into what that R squared is, what a good number is, what a bad number is. But let's go to our worksheets first. I don't know why it won't let me do that now, which will be over here. So we talked about the spread of the Walmart stuff. Guided activity 1. And this we're going to go pretty quickly through. I would love to have the 30 minutes in class for us to all have good arguments and everything. For each of the following situations, write down whether you think there's a true causal relationship. In other words, one thing is causing the other. And if you do think it's causal, list a possible causal agent. In other words, what the cause is that causes an effect. Then state whether this is a positive relationship, meaning that as one increases, the other increases, or a negative relationship, which means if one increases, the other decreases. We saw an example of a negative relationship previously, the pirates versus global warming. That was not causation, but it was correlation. Okay, so one of these is at least not fun sounding. Shootings per day in a city versus daily temperature in the city. Now, if we actually click this link, and I can't click it, unfortunately, but if we went to that, we would be able to find an article and give information based on that article. And what you see in that article is some actual evidence that shows that hotter cities tend to have more shootings, a higher frequency of shootings. So that's not saying that it's causal, but because you see a correlation, you can say it's possible that it's causal. We cannot say definitively cause and effect, but we see correlation, so we go, maybe we should study this a little bit. So what could be the possible causal agent? Well, hot temperatures can make people cranky. Hot temps make people cranky, irritable, whatever. So a hotter temperature would make me think there's a higher likelihood of having more shootings. So I would say this is a positive relationship. Higher temperatures would probably lead to higher amounts of shootings. Again, I'm not saying definitively, I'm saying it's possible. Are there lots of other confounding factors in there? Yes, definitely. But maybe the heat is one of the actual factors in that equation. The divorce rate in Maine versus the per capita consumption of Maine. You know what? Let me take it off annotate. I'll do this for at least one of them. It's just frustrating. No, here. Come on. Come on. See, this is why I didn't want to highlight it. Just takes a long time to get it right. I'm going to laugh if this link doesn't work anymore. That happened one time in the class. All right, so you still see my writing. Let's clear the screen. You got the answer for the first one. All right. Number of people who drowned by falling into a pool films Nicolas Cage appeared in. Wow. That, because you see these things kind of bend with each other, it seems like Nicolas Cage appearing in a film is causing people to drown in a pool. I don't know about that. Per capita cheese consumption. Cheese, that's a fun one. Versus people who died by becoming tangled in their bed sheets. That is a lot of people getting tangled in their bed sheets dying. That's terrifying. Now I don't want to go to sleep. here we go, though, the one that it was asking about, per capita consumption of margarine. So when we plot these data points together in a way that maybe we shouldn't necessarily, because they're two completely different things, like with the Walmart obesity rate and, sorry, number of Walmarts and obesity rate. So we have in one thing the margarine consumed, and it seems like over time margarine consumption is going down. Maybe because there's studies that say margarine's not the best thing for you. You should probably be eating butter. And I'm not telling you what to do. I'm just saying that maybe there are studies that say that. So maybe some people are getting with the times. And then the divorce rate in Maine. So the margarine consumed is over here in pounds. So that's going to be in a year. It doesn't actually say in a year. So you have to assume since they're done annually. Then the divorce rate per 1,000 people. So these are not percentages. This is per 1,000. It's actually like 0.4. I'm sorry, 46 per 100. Never mind. I went the wrong way. So they're going down. It's red, right? Yes, red. So is it like 4.95? So about 5 people per 1,000. And then it's kind of mostly going down, a little bump along the way, and then keeps going down. Back down to about 4, roughly 4.1 per 1,000 people. That'd be 0.4%. Yeah, I don't know why I'm trying to say too many things at once. I said it right the first time. Not the point of the problem, so don't worry about my verbal mistake earlier. So we see, oh, look, these things are, it seems like they're bending together. This had a big dip. This had a big dip. Then they both went up. Wow, that is fascinating. It seems like there is almost a perfect correlation. Whenever one does something, the other does something in the exact same fashion. They don't bend exactly the same. But again, did I necessarily have to have the height of 8 being the height of 5, roughly? No. I could have had a height of 8 be way up here, and then you're not necessarily going to see this pattern as well. So someone has decided to do this to make you think causation. I don't really think butter consumption is going to have anything to do with divorce rates. So I would say that there's no causation for this. Yes, there is a really good correlation, especially when you model them with those specific heights. I'm going to switch this to typing. Oops, and I'm on the wrong one. So no causation, which means spurious. If you even look at the title of that web page, it said spurious something. It had spurious in the title. 3, annual greenhouse gas emissions versus the Arctic sea ice extent. So in other words, how much ice we have. So a lot of people say that global warming is causing our ice to go away. So let's see. We'll do this one more time. Oh yeah, I gotta go off annotate. Oh, this is frustrating. Copy. You still see the no causation spurious. I'm not going to delete that right now. So you look at this, and they both seem to be declining a little bit. Now this was 1 month in March, this was 1 month in September for different years. So this blue graph is the level every March of a year. So this is March 1985, March 1990, March 1995, etc. This is the level every September. And we can see that it is slowly going down, very, very, very slowly. So the sea ice extent in millions of square miles, that's a surface area. So they do seem to both be going down over time. Then they have some extra information up here. September had the lowest September 2012 had the lowest ice extent ever, 44% below, 44% below 81 to 2010 average for that month. September 2016, sea ice extent was more than 700,000 square miles, blah, 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 blah. You can look at all this later on your own. We don't have enough time really with 5 minutes left. But what you want to think about is just, okay, well, global gases and emissions are increasing every year. This ice seems to be going down. It seems like a lot of people are saying that global gases cause global warming. Warming causes ice to melt. So we would then say that, yeah, I think that there is a causal relationship here. Come on, text, please, and thank you. So, greenhouse gases lead to an effect that warm the planet, which melt the ice. This would be a negative relationship. The higher the temperature, the less ice there is. Okay. Density of yoga studios versus obesity rate. Again, feel free to check out that chart on your own. But we end up saying that that's a possible causal. Not definitive, but possible. Wealth is a confounding factor. Because, all right, you might have a yoga studio next to you, but if you can't afford it, that's not going to do anything for you. But if you are someone, if you have a group of people that are going to yoga studios, they tend to promote healthier lifestyles. You're exercising, you're trying to have less stress. There's a lot of study that says stress can increase your obesity as well. And that would be a negative relationship. More yoga studios, if it is causal, would relate to less obesity. I have to clear everything so I can scroll. Sorry. Remember, you can always go back and pause, which I'm very surprised in my YouTube counts lately. Very, very surprised. Go watch my videos. Sale of winter boots at LL Bean in Freeport, Maine versus the sale of ice cream cones at the same store. Now, this one is my favorite of all of them. And they don't even give you a link for this one. They just ask you to think. Sale of winter boots versus the sale of ice cream cones. Winter boots have nothing to do with ice cream, right? Well, let's just think in basic terms. Let's not think about, people are buying this stuff all year. Let's think people are buying it when they need it. People need winter boots in the winter. So not a lot of people are buying winter boots in the summer. Yes, some people are. You find a great sale, buy them in the summer. But on average, you're buying things when you need them. So you buy your winter boots in the winter. And I know this is kind of a terrible argument for the average American, but a lot of us don't eat ice cream when it's cold outside. They only eat it when it's warm outside. If it's hot outside, you're more likely to go grab some ice cream, which is when you're not buying boots. So this one is actually fairly causal, and it surprises a lot of people if they don't think about it that way. But this would be very causal. And it's all based on temperatures. And it would be another negative relationship, because the more winter boots you're buying, the less ice cream you're buying. The more ice cream you're buying, the less winter boots you're buying. And when I say you, I mean an entire population. 6 is spurious. There's no correlation between that. 7 is a possible causal. There's a fun little chart there. The heat seems to lower test scores. Kind of like the heat seems to make people more likely to have a shooting. But don't take those too seriously. It's that those are possible causal. And again, this is not a type of question we're doing for homework or a test. This is just expanding our mind and trying not to just believe something. Oh, I see these two pieces of information correlate. One's definitely causing the other. not definitively, not for everything. So call it a day there. Please remember, you have a quiz that's due tonight. I've only seen 4 people turn this in so far. Please do not forget that. Do not get a 0. Please turn it in as a Word file or a text file. You have to submit it in Canvas. Don't email me your questions, your answers, that is. Your next Excel is due, your homeworks. I need to update the Chapter 8 homework due dates. As I said, I'm not going to officially assign anything from Chapter 9 in terms of homework, but that's not to say we won't discuss it. We definitely will. Our final's coming up Wednesday the 6th, and that will be it for us. Formula sheets are in Canvas. Your projects have been graded if you haven't seen that yet. Besides that, have a good day. We'll get this video uploaded. I'm crossing my fingers that Zoom doesn't screw me over again. Those of you who've seen, I'm very sorry about that short abridged version from last time. I can't even describe how frustrated I was with that. I talked to my teachers and someone else had it happen, which means it's probably gonna happen again, but that's my problem, not y'all's. Have a good one. We'll see you Wednesday. Crossing my fingers, please record.